What if I told you that the beautiful, trendy, clear glass bottle holding your expensive multivitamins on your sunny kitchen counter is, well, it's actually actively destroying the nutrients inside before you even swallow them?
I mean, it is a harsh chemical reality.
Hmm.
The UV light streaming through your window isn't just, warming up the bottle. It is quite literally severing the molecular bonds of highly sensitive compounds like riboflavin.
Yeah.
It's completely rendering them useless.
Wow. Okay, let's unpack this, because today we are bypassing the marketing hype on the supplement aisle. We are decoding the body's hidden engine room to understand the physical reality of what actually happens when you swallow these micronutrients.
Right, the actual chemistry of it.
Exactly. And to do this, we have a really fascinating guide from the Ingredientsage blog titled All the Vitamins and What They Do. But the twist here is that this guide is not written for you, the everyday shopper. It's actually a technical manual written for product formulators.
Which is exactly why diving into this material is so incredibly valuable for you. I mean, we operate in this landscape of endless wellness products and just total information overload.
Oh, absolutely. It's overwhelming.
It really is. So grasping the unvarnished chemical reality of these nutrients, how they interact, how they degrade, how they're stored, that's the ultimate shortcut to being well-informed. It lets you evaluate your own nutrition critically rather than, just relying on the promises printed on some sleek label.
To make sense of it all, the guide splits our vitamins into two distinct categories based on how our bodies actually process them. Let's begin with the long-term architects. So the fat-soluble vitamins, which are A, D, E, and K.
Right.
A good way to conceptualize these is as a long-term physiological savings account. Because they dissolve in fat, your body basically stores them in your liver and your fatty tissues for a rainy day.
And like with any savings account, the fundamental principles is balance. Because your body actively hoards these fat-soluble molecules, over-depositing them through heavy supplementation carries a really significant penalty.
So you can't just take a million of them and be fine.
Exactly. They do not flush out of your system easily, which severely elevates the risk of toxicity.
Let's look at vitamin A as the prime example here. Setting aside the basic, eat your carrots for good vision advice, the guide details how vitamin A acts as a regulator for cellular differentiation.
Yeah, it dictates how rapidly renewing tissues, like your mucosal barriers, grow and repair.
Right. And the recommended daily allowance is roughly 900 micrograms for men and 700 for women. But the source makes a very sharp distinction about the type of vitamin A you are actually depositing into that savings account.
Because the origin of the molecule completely changes how your liver handles it. You have preformed vitamin A, which is known as retinol, that comes from animal products like liver or egg yolks, and it features really heavily in supplements.
And that's the one we have to be careful with.
Yes. Because it is preformed, it bypasses your body's regulatory checkpoints and accumulates directly in your storage banks.
Yeah.
If you hit the tolerable upper intake level of 3,000 micrograms, it becomes highly toxic. In fact, the guide specifically warns against high-dose retinol during pregnancy because artificially high levels of this cell differentiation regulator can severely disrupt fetal development.
That is wild. But then you have the alternative, which is provitamin A. So these are the carotenoids like beta-carotene, which you find in plant sources.
Right, the stuff in carrots and spinach.
Yeah, exactly. And the body actually has to work to convert these plant compounds into active retinol in the liver. That extra metabolic step makes them much safer because your body simply stops converting them when it has enough.
Right, drastically lowering the risk of accidental toxicity from a plant-rich diet. What's fascinating here is how the body's built-in regulatory mechanisms protect us when we consume whole foods.
But those same mechanisms get totally bypassed by pills.
Exactly. They could be easily overwhelmed when we introduce concentrated isolated compounds in pill form.
That brings us to vitamin D. The guide classifies it as a hormone-like nutrient responsible for balancing calcium and phosphorus in the blood. Now, I do want to push back a little here.
Okay, go for it.
The RDA is 600 to 800 IU. If we evolved as a species to synthesize vitamin D directly through our skin via sunlight, why are these intake standards suddenly so difficult to hit without, eating fortified cereals or taking supplements?
It's a great question.
Are the RDA standards miscalibrated, or is our modern environment just fundamentally broken?
It is entirely an environmental mismatch. I mean, modern human behavior has vastly outpaced our biology. Yes, UVB radiation initiates vitamin D synthesis in the skin, but consider the current variables.
We're indoors all the time.
We spend the vast majority of our lives indoors, and when we do go outside, we wear clothing and sunscreen. which, to be clear, is very good for preventing skin cancer,
Right.
but it heavily blocks UVB rays.
Right. So what about winter?
Exactly. Add in variables like winter latitudes where the sun's angle is just too low for months at a time, or higher melanin levels in the skin, which naturally require more sun exposure to produce the same amount of vitamin D.
So the environment we currently occupy is drastically different from the one our biology actually expects.
Right. So supplementation steps in to bridge that environmental gap.
Mhm.
But again, the savings account rule applies here.
Ah, right. Toxicity.
Yes. If you indiscriminately take high-dose supplements and exceed the 4,000 IU upper limit, the guide notes it causes hypercalcemia.
Hypercalcemia, meaning too much calcium.
Exactly. You end up with too much calcium circulating in your blood, which can literally crystallize in your soft tissues and cause severe organ damage, which really underscores that these fat-soluble vitamins operate in a delicate, interconnected ecosystem.
Interconnected is the perfect word, especially when we look at vitamin E and vitamin K.
Yes.
So vitamin E is a lipid-soluble antioxidant. The RDA is only 15 milligrams, and vitamin K manages two major tasks. K1 activates the clotting factor, so you actually stop bleeding when you get a cut, and K2 handles bone remodeling.
To understand their interaction, we first need to look at what vitamin E actually does as an antioxidant. The body constantly produces free radicals. These are highly unstable molecules that are missing an electron.
Yeah, they're like molecular scavengers.
Yeah, and to stabilize themselves, they will violently rip an electron away from your healthy cell membranes, which causes structural damage. Vitamin E intervenes by basically donating one of its own electrons to the free radical.
Neutralizing the threat before it damages the cell.
Exactly.
But the Ingredientsage guide warns that if you decide more is better, and you megadose vitamin E above the 1,000 milligram upper limit, it starts actually interfering with vitamin K's territory.
And the resulting cascade is significant. High concentrations of vitamin E physically impair vitamin K's ability to bind to the specific enzymes required to create blood clots.
Wait, so you could theoretically be taking a massive dose of vitamin E to neutralize free radicals and inadvertently sabotage your body's ability to heal a physical wound.
What's fascinating here is that, yes, you are literally disrupting your body's clotting mechanism because you thought more of an antioxidant was automatically better.
That is crazy. Okay, so moving from the long-term storage banks, let's look at the daily operating cache of the human body, which is the water-soluble vitamins.
This encompasses vitamin C and the entire B complex.
Right. Because they are water-soluble, your body cannot hoard them. You basically extract what you need for immediate use and excrete the rest every single day.
They are the immediate resources driving everyday energy metabolism and structural repair. They require constant dietary replenishment.
Here's where it gets really interesting. The guide describes the B vitamins functioning like an intricate, collaborative cellular assembly line. It is not just a list of random letters and numbers. They physically hand metabolic materials down the line to generate energy.
It's a great analogy. If we follow a piece of carbohydrate down this line, thiamine, which is vitamin B1, is the first worker.
Okay, worker number one.
Its role is to grab that raw carbohydrate and initiate the breakdown process for usable energy. But because it isn't stored, daily intake from whole grains or legumes is mandatory.
And there's a specific vulnerability highlighted in the guide here, which is that chronic alcohol use drastically spikes the risk of B1 deficiency.
Yes, severely. The alcohol actively impairs the gut's ability to absorb thiamine and simultaneously accelerates how fast the kidneys excrete it.
Wow. So you are basically firing the first worker on the assembly line before they can even touch the carbohydrate.
The entire metabolic process stalls early. But, assuming thiamine does its job, it breaks the carbohydrate apart and energy is released in the form of electrons. Now, the material is passed to riboflavin, which is vitamin B2, and niacin, vitamin B3.
Right. And the guide notes riboflavin relies on molecules called FAD and FMN, while niacin utilizes NAD. Let's translate those acronyms for the listener. What are FAD, FMN, and NAD actually doing on this assembly line?
Think of them as molecular shuttle buses.
Okay.
Once thiamine cracks the carbohydrate open and those electrons are released, those electrons are volatile. They need to be transported to the mitochondria, the powerhouse of the cell, to be converted into actual physiological power.
Ah, so they need a ride.
Exactly. FAD, FMN, and NAD are the shuttle buses that load up those volatile electrons and safely transport them to the mitochondria. Niacin's NAD shuttle bus is also uniquely critical for fueling enzymes that repair damaged DNA.
And niacin has another really fascinating layer. The RDA is quite low, around 16 milligrams, yet the guide points out it has pharmacologic applications to manage cholesterol at massively higher doses.
It does. However, doing so without clinical supervision leads to severe flushing.
I've heard of this. It's when the skin gets really red.
Yes, the blood vessels dilate so rapidly the skin turns intensely red and hot, and there are genuine risks of liver toxicity.
It reinforces that concept of operating cache. You want the register fully stocked for daily transactions, but overloading the drawer just jams the entire mechanism.
Right. Now, moving further down the assembly line, the body needs to build complex structures like fatty acids. That requires stamping tiny carbon tags onto metabolic products, which is a process called carboxylation.
And this is handled by B5, pantothenic acid, and B7, biotin.
Yes, they are the workers attaching those carbon tags. Yeah. Finally, working on a parallel line, we have B6 pyridoxine, which synthesizes neurotransmitters for nerve signaling and mood regulation.
And B6 carries one of the most stark warnings in the water-soluble category. Because while we constantly flush out water-soluble vitamins, chronic daily intake of B6 exceeding the 100 milligram upper limit can actually accumulate in nerve tissue.
It's a huge issue. It causes severe neuropathy, which is active nerve toxicity.
So taking massive unregulated doses of a single B vitamin doesn't make the assembly line run faster. It throws the entire factory out of sync.
Perfectly said.
Which brings us to the ultimate collaborator, which is vitamin C. We all know it synthesizes collagen, but the guide emphasizes a critical interaction it has with dietary iron.
This is a masterclass in nutritional chemistry, and it's especially vital for anyone listening who follows a plant-based diet.
Right, because iron comes in two forms. You have heme iron from animal blood and muscle, which is easily absorbed.
And then non-heme iron, which is found in plants like spinach or lentils. But non-heme iron exists in a ferric state. Its molecular shape makes it incredibly difficult for the human intestinal wall to actually absorb it.
But if you introduce vitamin C to the digestive tract at the exact same moment, it forces a chemical reaction. Vitamin C literally donates an electron to the non-heme iron, reducing it to a ferrous state.
It literally changes the iron's molecular shape so the gut can easily pull it into the bloodstream.
Squeezing fresh lemon juice over a spinach salad isn't just a culinary choice. It is a targeted chemical intervention to unlock nutrients.
Exactly. Nutrition rarely happens in isolation. The workers on the line must collaborate for the nutrients to become bioavailable.
That collaborative necessity leads us directly into what I'm calling the vegan dilemma and the masking trap.
Oh, this is a big one.
Yeah. We have two specific B vitamins, B12, which is cobalamin, and folate, which is B9. The interaction between these two shows us exactly what happens when modern dietary choices collide with artificial supplements.
It creates an unexpected and very dangerous biological trap. B12 is essential for maintaining proper nerve function and fueling methylation cycles.
Let's demystify that term real quick. What is a methylation cycle?
Think of the methylation cycle as the body's molecular switchboard. It adds tiny chemical tags to your DNA to turn specific genes on or off, regulating red blood cell production and neurological health.
Okay, got it. However, B12 is almost exclusively found in animal-derived foods like meat, dairy, and eggs.
Which automatically places anyone on a strict plant-based or vegan diet at a high risk for deficiency unless they are deliberately consuming fortified foods or targeted supplements.
Right.
Furthermore, absorbing B12 isn't just about swallowing it. The stomach actually has to produce a transport protein called intrinsic factor to carry the B12 through the digestive tract.
And as we age, the stomach naturally produces less intrinsic factor, meaning older adults are also at severe risk of B12 deficiency, regardless of their diet. So let's introduce the second player here, folate, or B9. The guide outlines its role in DNA synthesis and cell division. Adequate folate is critical, particularly in early pregnancy, to prevent neural tube defects in a developing fetus.
Yeah, the needs jump up to about 600 to 800 micrograms a day.
We get natural folate from leafy greens, but we also consume large amounts of synthetic folic acid through fortified grains and man-made multivitamins.
And this sets the stage for the biological trap. When a body is deficient in B12, that cellular switchboard we talked about breaks down, and red blood cells lose their ability to divide properly.
So what happens to them?
Instead of dividing, they just grow abnormally large. It's a condition known as macrocytic anemia. Now, this is a very loud, easily detectable biological alarm bell.
Right. It shows up on a routine blood test, signaling to a doctor that B12 is dangerously low.
Exactly. But let's say this person, who is unknowingly deficient in B12, is taking a heavy-duty daily multivitamin packed with over 1,000 micrograms of synthetic folic acid.
How does the trap actually spring?
That massive flood of synthetic folic acid essentially bypasses the need for B12 in the cell division process. It forces those giant, abnormal red blood cells to finally divide and return to a normal size.
Wait, it visually fixes the blood, the anemia disappears.
Yes, the biological alarm bell is completely silenced.
Yet the underlying B12 deficiency remains.
If we connect this to the bigger picture, the folic acid has merely painted over the rest. The lack of B12 continues to silently starve the nervous system.
Yeah.
Because the easily detectable anemia was masked, the diagnosis is delayed.
Until the individual begins experiencing potentially irreversible neurological damage.
Precisely. It is a profound argument against taking high-dose supplements without a specific clinical indication.
It actively hides your biological reality. And speaking of the reality behind the pills, let's open up the manufacturer's secret playbook.
This part is fascinating.
Right, because the Ingredientsage guide is written for the chemists actually formulating these products. It strips away all the wellness marketing and reveals the physical warfare required to just keep these fragile molecules intact on a shelf.
We tend to view capsules as these indestructible little nuggets of health. But chemically, formulating a multi-ingredient supplement is like trying to host a diplomatic summit with highly volatile delegates in a single room.
Bringing it back to our earlier realization, the guide specifically flags light sensitivity. UV light actively degrades riboflavin. So, packaging a multivitamin in a clear glass jar purely for a trendy, clean label aesthetic that directly undermines the chemical stability of the product.
The formulator actually has to account for that degradation.
Yeah.
They must account for the environment outside the bottle and the war zone inside it.
The war zone inside.
Yeah, I mean, vitamin C's stability is wildly pH dependent. If the surrounding ingredients alter the acidity within the capsule, the vitamin C degrades before it ever reaches a consumer's mouth.
And vitamin K must be encased or packaged meticulously to maintain compatibility with other lipid-soluble ingredients that might react with it.
Right. A responsible formulator is constantly engineering delivery matrices to control moisture, temperature, and cross-reactivity.
Oh, just so the exact milligram count promised on the label actually survives the 6 months it sits on a warehouse shelf.
Exactly.
But the guide also admits that sometimes formulators add ingredients purely for psychological reasons. We see biotin, vitamin B7 prominently advertised on literally every hair, skin, and nail product on the market.
Even though the guide explicitly states that actual dietary deficiency in biotin is incredibly rare in modern diets. We receive ample amounts from nuts, seeds, and eggs to satisfy our carboxylation needs.
Yet it is packed into beauty supplements in massive doses simply to meet consumer expectations for potency.
It is the intersection of placebo and marketing. The biochemical data indicates the general population does not need supplemental biotin.
But if a brand formulates a beauty vitamin without it, consumers perceive the product as inferior.
It really forces the consumer to ask a critical question. Are you paying for an established biological necessity, or are you paying a premium for a marketer's understanding of your own psychological expectations?
So what does this all mean? We have navigated the long-term, fat-soluble savings accounts, seeing how overdepositing vitamins A, D, E, and K can overwhelm our liver and disrupt our clotting factors.
And we've traced the water-soluble daily grind, watching B vitamins hand carbohydrates down a cellular assembly line to fuel our mitochondria.
We also examine the severe consequences of trying to outsmart our own biology with synthetic megadoses, like watching folic acid silence the early warning alarms of B12 nerve starvation.
I think the overriding insight from this formulator's manual is that true physiological wellness requires respecting the chemistry of the body.
Absolutely. It relies on balanced dietary sources first, whole foods that naturally regulate absorption, followed by highly targeted clinical supplementation only when the environment or age dictates it.
I agree entirely. And actually, to leave you with a final thought to mull over, there is a quiet, easily overlooked detail buried in the vitamin K section of the source material.
Oh, what is it?
It notes that vitamin K2, which is the compound managing bone remodeling and calcium transport, is partially contributed by gut bacteria.
Wait, our internal bacteria are manufacturing our vitamins?
Yes. When you consume a meal, you are not merely feeding human tissue, you are cultivating a microscopic internal colony of bacteria residing in your digestive tract.
That is incredible.
In return for sustenance, that bacterial colony operates as an end-to-end manufacturing plant. It continuously synthesizes essential vitamins like K2 and delivers them directly into your bloodstream. You are not a single, isolated organism navigating the world. You are part human, part ecosystem.
Every bite of food either nourishes that internal factory or actively disrupts it. That fundamentally changes how I view the engine room of the body. Thank you for joining us on this deep dive into the hidden mechanics of your daily vitamins. The next time you find yourself staring at that brightly colored supplement wall, look past the clear glass bottles and the marketing buzzwords. Consider the chemistry, respect the ecosystem, and keep questioning the labels. We will catch you on the next deep dive.